Hello and welcome to Learn Yourself. Today we are going to learn chemical reaction. This chapter is under ICSE Standard 8 syllabus. Let us have a basic idea about when chemical reaction happens. How we get to know that this reaction has happened or this reaction is completed. So there are certain indications for that. First, color change. You can see some change in color when the product will form. Either it is from black to red or blue to green or something like that. So you will get to know that earlier it was this color and now it has changed. That means the reaction has been completed. Second, evolution of gas. When any effervescence you can see in the test tube, then we are believing that this reaction has been completed. That effervescence will stop once it starts and it will stop. That means that reaction has been completed. The indication is evolution of gas. Then in the form of heat, we are getting two indications. Either the heat is absorbed or the heat is evolved. If we will feel some heat, our beaker or test tube will get warm, then we will feel that heat has been evolved. And if we are boiling it or if we are giving heat to the reaction, then it will absorb the heat. So these are two different indications for the chemical reaction. Precipitation. When you are mixing two different solutions and you will get one solid compound at the end, it is known as precipitate. When in the chemical reaction you are getting any solid compound, it is known as precipitate, and that particular equation is known as, that reaction is known as precipitation reaction. Now let us see one by one example for each. Let us see some of the example for each and every indication. First, color change. Mercuric oxide, when you are heating it, you will get mercury and oxygen. Earlier it is red in color, and after the product you will get silver product at the end. So this is a color change. When red is completely becoming silver, we will get to know that our reaction has been completed. Evolution of gas. So here the hydrogen, when it is evolved, we will get to know that our reaction has been completed. When iron, any metal will react with acid, then it will gives us a product, a salt, and then a hydrogen gas. So when any effervescence will start and stop, we will get to know that this reaction is happening and this reaction has been stopped. So this reaction will show the indication of evolution of gas. In the form of heat, when it is absorbed, this reaction is known as endothermic reaction. And when heat is evolved, that reaction is known as exothermic reaction. Exhaust means exo. So it is liberating the heat. So there are two different examples for that. Nitrogen is reacting with oxygen and this is reversible reaction. So in this, the heat is getting absorbed. When heat is evolved, so this is exothermic reaction. When calcium oxide react with water, it gives us calcium hydroxide. And we can feel the beaker or test tube will get warm when this reaction will happen. Precipitation means we will get any solid compound at the end. When silver nitrate AgNO3 will react with hydrochloric acid, will gives us HNO3, nitric acid in the liquid form, and AgCl, silver chloride in the precipitation form. This sign we are showing for precipitate. That means it is in the solid form. The down arrow will tell us this will be as precipitate. So this reaction is an example of precipitation reaction. So there are four indications in terms of color change, evolution of gas, heat either getting absorbed or evolved, and precipitation formation. When we are learning chemical reactions, it is very important to learn how many types of reactions are there. So in standard 8 syllabus, there are total 8 type of reactions. Let us have a look on them. So direct combination reaction, decomposition reaction, displacement reaction, double decomposition reaction, reversible reaction, catalytic reaction, exothermic reaction and endothermic reaction. When we are learning this, for each and every type of reaction, you should remember the definition of it. You should remember one example each for each of the type of the reaction, and you have to explain the reaction. Let us see one by one each and every reaction with their suitable example. Let us learn the first type of chemical reaction, that is direct combination reaction. This is also known as synthesis reaction. So as the name suggests, when one compound or element is reacting with another compound or element and they are getting one compound, it is known as combination. What all reactants we are getting, they all will react together and they will form only and only one compound. There are 3 types of reaction in direct combination reaction. First one is compound will react with element. Element will react with element and compound will react with compound. So in all these 3 cases, they will only get one compound at the end. Whatever you are getting, a reactants A plus B, they all will combine and make only one new compound. That's why it is known as combination. What all reactants are there, they all will combine. So that's why it is known as combination reaction. So when compound is reacting with element, so we have taken here carbon monoxide. When it reacts with element oxygen, it will give us carbon dioxide. In the second type, element will react with another element and gives us compound. So carbon is an element, is reacting with element oxygen and gives us carbon dioxide. In third type, compound will react with compound. So calcium oxide is a compound, is reacting with water, that is also a compound. So calcium oxide and water will combine and gives us calcium hydroxide. So all these are example of direct combination or synthesis reaction. Let us see decomposition reaction. Decomposition reaction is exactly opposite to combination reaction. When any one reactant we are taking and we are heating it, it will decomposes into compound or element. So this is exactly opposite to combination or synthesis reaction. So there are 3 types of reactions. When we are taking a compound and we are heating it, we will get either compound plus compound or element plus element or compound plus element. So here in first I have taken calcium carbonate. When we are heating it, we will get calcium oxide plus carbon dioxide. So in this case, we are getting 2 new compound while we are decomposing this. Means when we are breaking this with the help of heat. When we are keeping this symbol, that means we are heating it. It requires heat. Decomposition reaction always require heat. So the triangle symbol on the arrow suggests that we are heating this compound. Second reaction, in which compound when we are heating, we will get element plus element. When we are taking mercuric oxide, we will get mercury plus oxygen. These both are element. So this also we need to heat. And in the third type of reaction, when we are taking compound and when we are heating it, we will get compound plus element. So in this reaction, when carbon dioxide we are taking and when we are decomposing it, we will get carbon monoxide and oxygen. If you will see carefully, all this type of reaction are exactly reverse to the combination reaction. We have taken in combination reaction compound plus compound and we were getting compound. Element plus element and we were getting compound. Compound plus element and we were getting compound. Here compound we are taking and we are getting either compound or element as a product. So this is a decomposition. When we are taking one compound as a reactant and we are heating it, when we are decomposing it as a product, as a result we will get either two compound or two element or one compound and one element. Decomposition reaction we are carrying out by four different ways. First is thermal decomposition, second is thermal dissociation, third is electrolytic decomposition and the last one is photochemical decomposition. So first one is thermal decomposition. The reaction we are doing, the decomposition we are doing with the help of heat, that is known as thermal decomposition. Thermal name suggests that heat. So thermal decomposition we are carrying out with the help of heat. So the example is a mercuric oxide. When we are heating it, we will get mercury and oxygen. The second one, thermal dissociation. This is thermal decomposition and this is thermal dissociation. These two are different. This is also we are carrying out with the help of heat. But this reaction is reversible, whereas this reaction is non-reversible. Once the mercury and oxygen has been formed, it cannot go back by its own. Here, ammonium chloride, when we are heating it, it will dissociate into two simple compound, ammonia and HCl. Once the reaction mixture will cool down, it again convert into ammonium chloride. So when we are giving heat, it will gives us ammonia and HCl. Once it is cooled down, it again converting into ammonium chloride. So this is the basic difference between thermal decomposition and thermal dissociation. In dissociation, the reaction is reversible, whereas in decomposition, the reaction is non-reversible. But both the reaction we are carrying out with the help of heat. Then third one, electrolytic decomposition. Name itself suggests that we are using electricity in this reaction. Electrolytic, we are using electricity. So when we are using water and in the water we are passing electric current, we will get hydrogen gas and oxygen gas. This reaction is an example of electrolytic decomposition. Then the fourth one is photochemical decomposition. Photochemical name itself suggests that it occurs with the help of sunlight. So the silver salt, this symbol suggests that with the help of sunlight. This star symbol always we are using for sunlight. So when a sunlight directly falls on silver salt, it will decompose into silver and chloride. They are very unstable salt. So in presence of sunlight, they can decompose. So the photochemical decomposition we are carrying out with the help of sunlight. Only this name has dissociation. Rest all are decomposition, decomposition and decomposition. Since this is dissociation, it is reversible reaction. Rest all are non-reversible reaction. Thermal decomposition, we are using heat. Electrolytic decomposition, we are using electric current. And photochemical decomposition, we are using sunlight. Now let us discuss displacement reaction. The name itself suggests that it displaces something in reaction. So one element will displace another element from the compound. So that is known as displacement reaction. In this, we require this activity series of matter. So this is known as activity series, and this series will tell us that which metal is reactive compared to another metal. So if you can see here, potassium, sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, platinum and gold are there. Also hydrogen is also there, even though the hydrogen is a gas, because hydrogen acts as a metal or proton donor. So scientists have given the place to hydrogen also. Now all the metals which are placed above hydrogen are known as active metal. Their reactivity is more compared to the below metal. Now whatever metal is placed above, they are very reactive. So the first metal is the most reactive metal and the last metal is the least reactive metal. That means potassium is more reactive compared to sodium. Sodium is more reactive compared to calcium, and calcium is more reactive compared to magnesium, and so on. So this is our activity series which tells us which metal is reactive compared to another metal. So let us check the definition of displacement reaction. The chemical reaction in which element placed higher in activity series displaces the element placed below it. That means potassium can displace sodium because potassium is more reactive compared to sodium. Sodium can displace calcium and so on. But calcium cannot displace sodium and sodium cannot displace potassium. Let us check one example. Here I have taken zinc, copper sulfate. When these two will react, it will form zinc sulfate and copper. It says that zinc is displacing copper from copper sulfate. So zinc is placed here and copper is placed here. Zinc is upon the copper. That's why zinc is very reactive, and that's why it could be able to take the place of copper. If this reaction has been reversed, for example it is ZnSO4 plus Cu will be there, then this reaction cannot possible because Cu is not reactive compared to Zn. It is less reactive, so it cannot take the place of zinc. Let us check one more time the definition, that chemical reaction in which element placed higher. So zinc is higher than copper. Activity series displace the element placed below it. So all this element can displace copper, but copper cannot displace all this element. To remember this type of reactions, you have to remember this sequence of activity series. Then only you will get to know that which metal will displace another metal. Double decomposition reaction. The name itself suggests that the decomposition will be doubleized. There will be two different decomposition in one single reaction. We have seen decomposition in which one reactant will decompose into compound or element. Here two reactants simultaneously will decompose. So that's why it is known as double decomposition reaction. Now let us first see the definition. Reactants are decomposes and give two new compound by exchanging their radicals. How they are exchanging their radicals? For example, this is one compound, this is another compound. So here X is a positive radical, Y is a negative radical. A is a positive radical, B is a negative radical. So they are exchanging their radicals. So positive radical of first will take and will go with the negative radical of the second reactant. It cannot go with positive. Positive radical cannot combine with another positive radical. So they are exchanging their radical. And this negative radical will go with the positive radical of second reactant. In one compound there will be only two radical, one will be positive, one will be negative. So they are exchanging like this, and as a result we are getting X plus B minus. This is one compound, and the second one is A plus Y minus. This is second compound. So the reactants both has been decomposed. Both have been decomposed. How? Earlier it was XY, now it is XB. When we are breaking the reactant, it is known as decomposition. So they both are decomposes. So they both are decomposed. How they are decomposed? That by exchanging their radical with each other. So in double decomposition reaction, there will be two reactants and they both will exchange their radical and we will get two another new compounds. There are two types of double decomposition reaction. First is neutralization reaction. Second one is precipitation reaction. What is neutralization reaction? When acid will react with base, it will gives us salt plus water. What is acid here? HCl. Hydrochloric acid will react with base, that is NaOH, and will gives us salt and water. This is neutralization reaction. Second one is precipitation reaction. What is precipitation reaction? When any compound in aqueous form, when we are writing in the bracket AQ, that means the medium is aqueous. When we are dissolving that salt in the water medium, that is known as aqueous solution. So one compound in aqueous solution, another compound is also in aqueous solution. That means two solution we are mixing it with each other and we are getting one compound in aqueous medium and another compound we are getting as a precipitate. That means when you are mixing two liquid, two aqueous medium compound with each other, you will get some solid compound. And when you are filtering it, one solid compound will come as a residue, and whatever left the solution in that, the another compound will be there. So let us take one example, that is sodium hydroxide will react with silver nitrate and it will gives us sodium nitrate plus silver chloride. So when two solution we are mixing it together, we will get NaNO3, sodium nitrate in liquid and AgCl as a precipitate. So you can filter it out and as a residue you will get AgCl, and in the liquid your another compound will be there, that is sodium nitrate. So there are two subpart of double decomposition reaction. That first one is neutralization reaction and the second one is precipitation reaction. Catalytic reaction. So what is catalyst? Catalyst is a compound which enhances the rate of reaction or suppress the rate of reaction without taking part in the reaction. So basically the catalyst is, it changes the rate of reaction. It will change the speed. So if catalyst is a positive catalyst, then it will increase the speed. If the catalyst is a negative catalyst, it will decrease the speed of reaction. Now there are total three type of catalytic reaction, and in that one is positive catalyst, second one is negative catalyst, and the third one is promoter. positive catalyst will increase the rate of reaction. When we are taking hydrogen peroxide, we are decomposing it, we are using manganese dioxide. So manganese dioxide is catalyst and it will increase the speed of reaction and we will get water and oxygen. Negative catalyst. So negative catalyst, we are using alcohol. It will suppress the rate of reaction. It will decrease the speed of reaction. The third one is promoter. Promoter is a compound we are using along with the catalyst. So it will help catalyst to enhance the rate of reaction. When we are taking this example, nitrogen will react with hydrogen. We are using iron plus molybdenum Fe or MO at the temperature 450 to 500 degree Celsius. We will get 2 molecules of ammonia. Here this Fe is catalyst and molybdenum is promoter. So molybdenum will help iron to increase the rate of reaction. So molybdenum is not a catalyst, it is a promoter which will help catalyst to increase speed of reaction. So catalytic reaction is a reaction which takes place with the help of catalyst. And there are 3 types of reaction: positive catalytic reaction, negative catalytic reaction and the reaction which will occur with the help of promoter. In our body, enzymes are also one type of catalyst which will enhance the rate of our metabolic process. Oxides. What is the meaning of oxide? When any metal or non-metal react with oxygen and they will form the respective oxide. Any metal, for example potassium, will react with oxygen and form potassium oxide. Any non-metal, for example carbon, will react with oxygen and form carbon dioxide. So they are known as oxides. Now we have to learn that what are the nature of this particular oxides. So there are basically 2 types of oxides. When non-metal react with oxygen, they are forming non-metallic oxide. When metal will react with oxygen, they are forming metallic oxide. Let us first see non-metallic oxides. In this, the nature of oxides will be acidic. For example, sulfur dioxide and carbon dioxide. How we will get to know the nature? That when we are mixing those oxide with the water, it will generate acidic medium, then they are acidic. If it will generate basic medium, then they are basic. So when the carbon dioxide will react with water, it will gives us H2CO3. This is a carbonic acid. So that's why the oxides of non-metals are always acidic. Sulfur dioxide when react with H2O, it will gives us sulfurous acid or sulfuric acid. So always non-metallic oxides will gives us acid. Then some oxides are also neutral. For example, NO and CO. This is carbon monoxide and they will do not react because they are neutral. So in non-metallic oxide there are 2 types, acidic oxide and neutral oxide. Now let us see the metallic oxide. When metal will react with oxygen, it will generate metallic oxide. Metallic oxides are basic. For example, potassium oxide and calcium oxide. When we are mixing this oxide with water, we will get a basic medium. This is calcium hydroxide and this is a base. So that's why they are basic in nature. They are also amphoteric. Now what is the meaning of amphoteric? For example, zinc oxide and lead oxide, their nature is amphoteric. Amphoteric means when they are reacting with acid and base, they will gives us salt plus water. So what is the meaning of amphoteric oxides? The oxide, when they are reacting with acid and base, they will give us salt plus water. Then their nature is known as amphoteric oxide. So in non-metal there are two types, acidic and neutral, and in metallic oxide there are two types, that basic oxide and amphoteric oxide. Oxides, and this oxides reaction we are studying with respect to when a reaction is decomposition reaction and it is forming oxide. So here decomposition reaction to form oxide, the meaning of this is when we are doing a decomposition reaction. What is a decomposition reaction? When we are taking reactants and they are decomposes and it will give us products. So it will be one reactant and when this reactant, when it will decompose, it will give us multiple products. So in generalized term we can also say we are breaking down the reactant. So here I have written activity series of metals. So potassium and sodium are very reactive metal. These are moderately reactive metal and these are very least reactive metals. So carbonates of potassium and sodium cannot decompose, means they are so strongly attached with each other, and here we are doing thermal decomposition. Now what is thermal decomposition? The decomposition which helps with heat. So when we are giving a heat to any substance, it will break down, it will decompose and give us products. So all these reactions are thermal decomposition reactions. So their carbonates, potassium carbonate and sodium carbonate cannot break, we cannot break them with the help of heat. So that's why I have put cross here. They are strong bonding molecules. Now nitrates. So sodium nitrate will decompose in presence of heat and will give us NaNO2 and oxygen. Again the hydroxide of potassium and sodium we cannot break with the help of heat. Then about these metals which are moderately reactive. So from that we are taking one example, that is calcium carbonate. In presence of heat we can decompose into calcium oxide and carbon dioxide. Calcium nitrate will decompose in the presence of heat and it will give us calcium oxide, NO2, nitrogen dioxide and oxygen. Calcium hydroxide will decompose and will give us calcium oxide and water. These are moderately reactive metal and all the form of this matter like carbonates of these metals, nitrates and hydroxide we can decompose in the presence of heat. But this is a special case when these metals are very reactive, we cannot break them in presence of heat. Now least reactive metal like mercury and silver. So when these metals, carbonate will be there and they will decompose and will give us metal, oxygen and carbon dioxide. So this is a generalized reaction. We can frame this reaction like Ag. So Ag carbonate. So silver carbonate Ag2CO3 and it will give us metal. So silver, then oxygen and carbon dioxide. If it is for mercury, then mercury carbonate will be there. Metal we will get is mercury, then oxygen and carbon dioxide. So that is how we can frame the reaction from generalized equation. Now nitrates. So when Ag and Ag will be there, silver and mercury will be there. When nitrates of this metal will decompose, it will give us metal, nitrogen dioxide and oxygen. Here carbonate is there, so that's why we are getting here carbon dioxide. But here nitrate is there. So it is NO3 is there. So because of nitrogen we are getting here nitrogen dioxide. Now hydroxide of silver and mercury are formed very rarely. So there are no reactions for this decomposition. So when we will see all this reaction, then at the end of this decomposition reaction we will get oxide of that particular metal. So when this reaction will happen, we will get as a product the oxides of this particular matter. So that's why this decomposition reactions are generally we are performing to form oxides of that particular matter. Earlier we have seen displacement reaction, double decomposition reaction, combination reaction and decomposition reaction. These are some of the more reactions which are categorized into reversible reaction, catalytic reaction, exothermic and endothermic reactions. So let us see one by one. So here this is termed as reversible reaction. Name itself suggests that when any reaction will happen, the product will form. But after certain amount of time, after certain time, once the product will form, it will go back to its original reactants. The products react together to form the original products. So once the product will form, again they will react among themselves if there are two products. And if one product is there, then it will decompose and it will give us the reactants. So there are two possibilities. If there are multiple products, then they will react among each other and will give us our reactant back. And if there is only one product, then it will decompose and give us our reactant back. But the thing is, this is reversible reaction, so that means once it happens, once it will occur in forward direction, once we will get our product, then again we will get our reactants back. That is the meaning of reversible reaction. So let us see some more examples based on this. So sulfur dioxide when react with oxygen. Now these are the condition that vanadium pentoxide, the formula is V2O5, with the temperature 450 degrees Celsius, we will get 2SO3. This is sulfur trioxide. So once this will form, it is reversible reaction. Again, it will give us back our reactants. Then second reaction. When iron is reacting with water, in presence of heat, it will give us Fe2O3 and 4 molecules of hydrogen gas. Again, this will react with themselves and it will give us Fe and H2O. When we are heating calcium carbonate, we will get calcium oxide and carbon dioxide. And this is reversible reaction. So again these products will react among themselves and we will get the calcium carbonate back. When nitrogen, this reaction is important. When nitrogen is reacting with hydrogen with condition that Fe as a catalyst and at 450 degrees Celsius it will give us ammonia. Now this ammonia will again decompose and will give us nitrogen and hydrogen back. This is reversible reaction. Next reaction is when nitrogen is reacting with oxygen at 3000 degrees Celsius, we will get 2NO, that is nitric oxide. When HCl we are heating at less than 500 degrees Celsius, then we will get hydrogen and chlorine gas. So these are some of the example of reversible reaction. Earlier we have seen the number of types of reaction like combination reaction, decomposition reaction, displacement reaction and double displacement or double decomposition reaction. Here we are going to study about catalytic reaction. Now what is the meaning of catalytic reaction? In reaction where we are using a catalyst, that reactions are known as catalytic reaction. Now what is the function of catalyst? It alters the rate of reaction. So there are two types of catalyst, positive catalyst and negative catalyst. Positive catalyst will accelerate the rate of reaction. It will give speed to reaction. That means in usual time, how much ever the products we are getting, it will accelerate the reaction, the rate of reaction. So in smaller period of time, we will get more yield. That is the function of catalyst and that is positive catalyst. Negative catalyst will decrease the rate of reaction. Sometimes what happens when reactants are very reactive, very speedily they will react with each other, but sometimes they will liberate so much amount of energy or there are some side effect of that speed. So at that time we have to lower down the rate of reaction. We have to slow down the rate of reaction. At that point of time, we need to use negative catalyst. So it will decrease the rate of reaction. So here let us discuss some of the example, and in this example we need to remember that what all catalyst we have used in this. When H2O2 hydrogen peroxide we are taking in presence of MnO2, that is manganese dioxide, we will get water and oxygen gas. Then sulfur dioxide, when reacting with oxygen, we are taking as a catalyst V2O5. This is vanadium pentoxide at the temperature 450 degrees Celsius. So we will get sulfur trioxide. When nitrogen is reacting with hydrogen in presence of iron and molybdenum, then rate of reaction will increase and at a temperature of 450 to 500 degrees Celsius. These two reactions are, earlier we have seen the reversible reaction, and these two reactions we can also mention in reversible reaction. Also we can mention them in catalytic reaction. So here we will get ammonia. When ammonia is reacting with oxygen in presence of platinum at 700 to 800 degrees Celsius, we will get NO, that is nitric oxide, and water molecule. So these are some of the example of catalytic reaction. Now one important point to discuss in this is enzymes. Enzymes are also working as a catalyst in our body. That there are two examples of that. That pepsin is an enzyme which secrete in our stomach, and it will accelerate the conversion of protein into amino acid. So this conversion happens, and it will happen at a faster rate with help of pepsin. So pepsin is an enzyme which gives a catalytic effect to this reaction, to this conversion. So this can be asked in fill in the blanks. Then lipase is another example of enzyme which secretes in pancreas, and it will help us in breaking down of starch and fats. So these two you need to remember. One is pepsin and second one is lipase. So these reactions are very easy to understand, and they are scoring. This reaction may come in an exam in fill in the blank or to complete the reaction, or they simply just ask that give an example of one catalytic reaction, or they can also ask like give an example of catalytic reaction where manganese dioxide is used. So you have to remember the complete reaction along with its catalyst.